how to design and maintain a high-performance data pipeline, best practices by the Agoda Engineering. I'm super excited about this blog post because the latest one from Agoda was clear, concise, down to earth by people who know how to think clearly. This is expected to be a good one by Lalit. Data pipelines are essential for managing data flow from various sources to a target destination. The BI Infra Ops team at Agoda has presented a comprehensive guide on best practices for designing, monitoring, and ensuring the quality of data pipelines. What is a data pipeline? Yeah, I always like this. They begin from the basics. Great job. What is a data pipeline? Data pipelines are processes where data is extracted from the sources, single or multiple, transformed into a suitable format, and loaded into a target, mostly a table. Here, so we extract some data from several sources, we transform them and load them into a target. Designing a healthy data pipeline. When creating a data pipeline, one of the most important things that should be considered is how to create a healthy one. A healthy data pipeline is critical for ensuring we can use its data effectively for strategic decision-making and operational efficiency. For our data pipelines, we are unhealthy. If our data pipelines are unhealthy, the data will not be able to be delivered on time or even cause data issues downstream users. Designing data pipeline properly could make it reliable and minimize data loss or system downtime. It should have error handling, data recovery, and monitoring mechanism to detect and address issues promptly. When our data pipelines are well designed and optimized, the data will be processed much faster and cost efficiently, significantly reducing the time for data to be ready. So the question is how to make this. How to make this healthy, process fast, less issues. I'm not saying without issues, less issues. Moreover, as our data requirements change fast, our data pipelines should also be flexible and adaptable to these changing requirements. New data sources, new data formats, and new data schemas should be accommodated with little effort. A well-designed data pipeline can scale to handle increasing data volumes and sources without significant performance degradation. This scalability is crucial as organizations grow and generate more data. Our data grows as we grow. Our data pipeline should be able to scale and handle continuously increasing data volumes without decreasing performance. As a result, several factors must be considered to have a healthy data pipeline. This includes data. 1. Data. Where is the data stored? What is the data behavior? 2. Resource used. How much resources should we allocate for our data pipeline? Partitioning. How should we partition our table in Hadoop for job scheduling? How frequently should our data pipeline run? 5. Data dependency. Does the pipeline depend on the data of other tables? Let's repeat it. This is important. So basically when they design, they think about the following. The data, where is the data stored? What is the data behavior? 2. The resources used. How much resources? Yeah. Partitioning. How should we partition our table? 4. Job scheduling. How frequently should our data pipeline write? 5. Data dependencies. Does the pipeline depend on the data of other tables? I would claim these are some low-level technical requirements. There are also some high-level requirements, like who can produce data. Is any data can be consumable by other parties? Let's see if this is also touched, or maybe this is only on the technical aspects, which is also good. We will go through each factor individually and give some generic examples of how these factors affect the design or data pipeline at Agoda. Resources must be allocated appropriately to ensure that the pipeline runs efficiently. Partitioning can improve write performance and decrease runtime. Job scheduling must take into account the data usage, SLA, job duration, and freshness of the data source. Data dependency must be considered when one job needs another job to finish first before starting. 1. Data. The data source and data behavior determine how the data will be processed. The data source refers to where the source of the data is stored in MS SQL or Hadoop, as well as where the data will be stored. The data behavior could be whether the data changes over time or what the granularity level of detail the data is. In one of our data pipelines at Agoda, we divided the process into 3 sub-processes based on the characteristics of data we are working with. This data pipeline loads the data into fact table in our data warehouse. This table is called the fact booking table. This fact table stores data about bookings at booking level. Our design is based on the star schema method. The 3 sub-processes include 1. Original column process, this process column that has no change, static. B. Implementation, snap the value since the booking was created, ignore change. C. Source, MS SQL plus Hadoop. 2. Current column process, this processes column that can be updated over time. Dynamic implementation, all values can be changed if update in source. Source, MS SQL Hadoop. Flatten process, update dimensional columns. Implementation, get value by joining dimension table. Source Hadoop. Each subprocess is suitable for different types of data and needs to be implemented differently. This shows why understanding the data is crucial in designing a pipeline. 2. Resources used. The resources used refers to the amount of resources used for processing our data in a data pipeline. The amount of resources allocated for our data pipeline is another factor that should be able to be specified. So that they allow to specify these. If too little resources are allocated, pipeline takes too much time to finish. Risk of pipeline failure due to not enough resources. If too many resources are allocated, negatively affect each other pipelines, waste of resources. At Agoda, most of our data pipelines run on Apache Spark. Allocating resources to Apache Spark application is essential for ensuring efficient and optimal performance of the data pipelines. Spark allows you to set resources configurations for individual Spark jobs or stages within jobs. To fine-tune resource allocation, you could use Apache Yarn or Kubernetes to help manage and allocate resources to Spark applications. Back to our fact booking table. Apart from data, we also separate the processes in our pipeline based on how much data is consumed in each round. Hence, resources are allocated to each process based on data volume. So they check how much data is consumed and automatically give the resources, or they allow people to input it. Let's see. Processes that consume higher data volume are run less often and avoid consuming too much resources confrequently. So processes that runs on a monthly, they would need more resources because they have more data to process, and processes, that is obvious. Processes that run overly usually need less resources. In Spark, you can adjust several things, such as the driver memory and number of executors that best suit your pipeline. For example, a process that consumes a high volume of data tends to require more driver memory and more executors. So far, makes sense. Allocating Spark resources based on data volume. So you actually give in input fields, in text boxes, how much memory you want to provide to the driver, to the executors. Here we have 20 gigabyte memory for high data volume, and here we have 8 gigabyte memory to a low volume. How many executors? 6 for low volume, 120 for high volume. At Agoda, we also have dashboards made by our engineering team to track several Spark metrics used by our pipelines. This dashboard can be used to monitor our Spark applications. So in the dashboard, you see, I guess, for a specific Spark execution, how much time it took, what was the memory consumption, then additional metrics. So this is the part of the monitoring where we can monitor metrics about our Spark applications, how many bytes were shuffled. We see 1 million megabyte. And also it has, I think, something like static tips of optimization. Ideally, the shuffled read size peak should be between 120 megabyte. So they have some tips. A higher number of shuffle partitions results in too many tasks with smaller partition size. 3. Partitioning. In Hadoop, partitioning refers to the process of dividing and organizing data into smaller, more manageable subsets called partitions. We mostly partition our tables based on particular columns in our tables. Partitioning the table properly can improve the writing performance and decrease the runtime for your data pipeline. These are some factors that could be used to identify the table partition. Size and number of partitions. The size and number of partitions should not be too much or too little. Distribution of data. We want the data to be distributed equally to all the partitions. Back to our fact booking table. In the fact booking table, we used data month, which is the month of the booking date as the partition column. So for each row in fact booking all, they have the month 2023-06. And then inside this, they have a Parquet file for each day. Yeah, so for each month, we have a partition which we can refer to as a logical folder. You can quickly find there things it should reside in our workflows. Why month of the booking date as partition? The number of bookings is distributed equally across months of booking days. Why month, not day level? If we use the day of the, great question, if we use the day of the booking date, the size of the partitions would be too small. There would be too much number of partitions. So if they use month, the size for each day is 3 megabyte. I would think it would be more for booking. If they use day, they only have 100 kilobytes. So they have 12 partitions, one per month, each 3 megabytes. If they use day, they would have 365 partitions, which would negatively impact performance. Of course, it depends on the size of the Parquet files. If they manage to have 3 megabytes per day, then this is a good. In reality, it is often more practical to start with a reasonable partition size based on an initial analysis and then fine-tune it through performance testing. Measure the impact of different partition sizes on query performance and resource utilization to find the optimal balance for each use case. Yeah, this makes sense. Measure it. See which partition is best for you. Job scheduling. In a normal circumstances, we would not manually submit and run our pipelines. Job scheduling is the way that we automate our data pipelines. With job scheduling, we can determine in advance when and how frequently our pipeline should run. The main consideration when setting up a job scheduling pipeline is the frequency of your job schedule. The frequency of the job scheduling pipeline can depend on 1. Data usage. If data is used once a day, for example for a daily report, we could schedule the job to run once a day. If data is used heavily, we could schedule the job to run more frequently. SLA of the data. Less SLA times means that the pipeline should be run more frequently. Pipeline duration, how much time is needed to run a single round of the job, freshness of the data. If the source data is updated once a day, we do not have to schedule the job so frequently. I like this down to earth tips, looks good. 5. Data dependency. Sometimes your data pipeline might rely on data source that is loaded by another upstream pipeline. This means that there is a data dependency going on in your pipeline. Data dependency should also be taken into account when designing a data pipeline. Here is an example of why data dependency is crucial when designing your data pipeline. Example use case. Pipeline B loads data into table B runs at 10:30. Data B loads data by using table A as a source table. Pipeline A is a job that loads data into table A, runs daily. Pipeline B depends on table A. Pipeline A loads into table A at 10:40. Pipeline B starts at 10:40. If no data dependency rule is set on pipeline B, it would start at 10:30 a.m. and the data loaded into table B would be incomplete. So they need dependency so that job B would start only after job A finishes. How they do it, they didn't mention. I guess job scheduling tools already allow for this. Monitoring your data pipeline. After you have the data pipeline in place, what is needed next is a way to monitor the pipeline. Monitoring your data pipeline is crucial to ensure that it runs smoothly and that any issues are quickly identified and resolved. In the BI teams at Agoda, we mainly monitor the duration and the status of the submitted data pipeline. We see various monitorings. When our pipelines are submitted to Spark, there are log tables that store information about the submitted pipeline. This information, so we store metadata and log data and operational data about the logs. Great. In S3, this information includes when the pipeline started, ended, whether the pipeline succeeded or failed, and many more. The Hadoop data team is responsible for the platform used to run our pipeline. So they have a Hadoop data team platform responsible for the running the pipelines and manage all these logs. As a BI team, we created a pipeline or ETL that consolidated the data from logs and loaded the data into the destination table, where the data is ready to be used in dashboards. Then we created several dashboards for monitoring and submitted pipelines. So the data team, the Hadoop data team, was responsible to run the data and write the logs. The BI team, they consolidated the data from logs and loaded them into dashboards. And then the application teams have this ready for them. These are some examples of our dashboards used for monitoring, duration of pipelines. So they are presenting here a couple of dashboards. Average duration of the pipeline, median duration, latest finish on duration, current duration, plus a graph or running duration versus average. Yeah, so they monitor mainly number of errors that have. I guess these are standards. So these dashboards repeat over and over again in multiple companies. This is the standard dashboard for monitoring Spark jobs. I saw this 15 years ago, like these dashboards, so it's still relevant today. Dashboard for monitoring the status of the pipeline, succeeded or failed. Looks similar to Airflow. Each green is running. We see here a failure in the middle. Green, the width of the green is the duration. Ensuring data quality. The product of our data pipeline is data. So ensuring data quality is essential. Data quality can be measured in terms of freshness, integrity, consistency, completeness, and accuracy. We go through each aspect individually and how we test each data quality aspect here at Agoda. Freshness. The freshness of the data refers to the timeliness of the data. This is to ensure the data is available to be used in timely manner. At Agoda, we built an in-house tool to track the freshness of the data of our tables. For example, we set our freshness tool in the fact booking table to track the booking datetime column. Also repeating a pattern, you track some datetime column in your data and you compare it to the current date, and now we know the freshness. So fact booking table SLA is 6 hours. The tool will notify us if the latest booking datetime is older than 6 hours. Various reasons we can cause data delays. This could be the pipelines failing or taking longer time than usual. So, as expected, this blog post from Agoda is really great. integrity, and completeness. In most cases, data integrity refers to the uniqueness of the data. Data completeness refers to the completeness of the data, no null or empty values. For example, table A has column ID. This ID column uniquely identifies each record in table, so there should be no two rows with the same ID. So this here they can check the data integrity, I guess, with this to make sure no two columns with the same value. Or if they know that the value cannot have null, they can check this. Another example of completeness of the data is when we do not want some value in the table to be null or empty. In the above picture case, we do not want value 1 to be null. At Aguada, we validate data before writing it into the target table. If the data fails the integrity check or completeness, the pipeline will not write the data into the target table. Accuracy. Data accuracy ensures that the data is accurate by checking the current data against the previous trend. So they look at some variable on a graph and they see that the values are between 0 to -5, and then suddenly there is a spike of 15. This is considered an anomaly. At Aguada, our BI teams use the tool called Third Eye to help us detect anomalies in our data. Third Eye can investigate deviation. This is going to be interesting to look at our next session here. What is Third Eye? I'll make a video about this. To help us detect anomalies in our data, Third Eye can investigate deviations in metrics anomalies with interactive root cause analysis. Nice. The above picture shows us an example of how Third Eye helps us detect anomalies in our data. It compared the current value against the predicted value based on the previous trend. If the difference exceeded the threshold, Third Eye will notify us about the anomaly. Third Eye is also very easy as it provides 4 basic instant algorithms to calculate the predicted value. More about Third Eye, GitHub, Third Eye. Consistency. Data consistency ensures consistent data between two places, source and destination. Our BI team uses a tool called Quilliap to check the consistency of the data after the data pipeline successfully loads the data into a table. The main concept of Quilliap is that we have a source dataset that contains data from source tables and destination dataset that contains data from destination tables. With the source, and we compare the data because the data on the destination is calculated from the source, so Quilliap should be aware of these changes. Let's see. Contains the data from the destination table. The data in the source and destination tables should match. Yeah, depends, unless you do some changes. So if the data is different in the source and destination, then Quilliap notifies a failure. It typically triggers the Quilliap test to run once the pipeline completes, testing the consistency of the loaded data. More about Quilliap on zendesk.com. Quilliap, data monitoring. Data monitoring is the process of collecting, analyzing, and responding to the result of the data quality testing result. At Aguada, we have an in-house centralized alert system called Hedwig. Hedwig can receive testing results from various data quality testing tools mentioned in the previous sections and send alerts through email and Slack to notify us when the testing fails. This allows for quick and efficient responses to any unexpected changes in the data. So they have Quilliap, Third Eye, GoFresh, various validation tools to do some testing. They have Hedwig to send a notification or Slack, email, or on call, then open Jira tickets, and then they have the monitoring to say. This is good. This is really down to earth and interesting post. I mean, I really like how clear they are. We also automate the creation of Jira tickets when Hedwig sends alerts. This allows us to track the start and end time of the data issue, the root cause, and how it's solved. Example of email and Slack, nice. Alert from Hedwig. They have some email about freshness issue, some instructions, how to deal with it, and job processing alert failed, description failed. We also have dashboard that summarizes all the Jira tickets created by Hedwig when it sends alerts. So you can look at all the Jira tickets that were created, a summary. This will give you her picture and maybe to correlate things when an issue started at which week. Nice. Good job. Wow. In conclusion, designing, monitoring, and ensuring the quality of the data pipelines is crucial for managing the flow of data. By following the best practices presented by the BI Infra Ops team, data pipelines can be designed and maintained to ensure their efficiency and accuracy. Disclaimer, the approaches listed in this blog post are tailored to Agoda's specific requirements, and all the tools we mention in this blog are used internally only. This was awesome. I really liked it. They really did a good job. I mean, the description was mainly technical and low level, but it was good to have this overview of all the tools that you can use, and some mentioning of some open sources like QuilyApp and QuilyApp Third Eye to monitor anomalies, QuilyApp to compare results of data, GoFresh to check how fresh is your data with relation to a column. Then you aggregate it all, you see the high-level picture. So we have the global picture on how they do the data quality and monitoring, I guess. This was how to design and maintain high-performing data pipeline from Agoda, where they focused on the 6 aspects of one, the data, where is it stored, resources, how many resources they allocate, the partitioning they do, they prefer the month with megabytes of scheduling of the jobs, and data dependencies and monitoring.